In this video, I'm going to be working AP Pre-Cal Homework 6-4. So we're going to be doing more trigonometry on the unit circle. It's just this time we're going to be going to the extreme values, like pi over 2, 3 pi over 2, 0, and pi, and then also outside the interval 0 to 2 pi. So kind of negative theta values, values of theta larger than 2 pi. All the stuff we haven't done yet. So I'm going to kind of remind you two of the big things we picked up off the lesson. Our real official definition of sine and cosine are now going to be, for cosine, the horizontal displacement from the y-axis on the unit circle, and for sine theta, it'll be the vertical displacement from the x-axis on the unit circle. And as a result, we can calculate tangent and cotangent by taking like the y-coordinate over the x-coordinate for tangent and the x-coordinate over the y-coordinate for cotangent. That'll be particularly useful because some of these things are going to not exist, and we're going to know that because we're dividing by 0. Okay, so we're going to go, and I might also label, we've got these axes here. I might as well draw a circle in. Okay, I think that'll do. That's about as good as I've got. I'm going to label some theta values. Like right here where we're beginning, that's theta equals 0. Up at the top, that's theta equals pi over 2. Kind of some spots we've neglected a little bit. That's going to be theta equals pi. Oh, goodness. So I was saying this is theta equals 3 pi over 2, and then if I go all the way back, I'll have theta equals 2 pi. And we could continue going, counterclockwise, and we go beyond 2 pi, but we'll just figure out those situations when we get to them, right? That was also kind of one of the messages from the lesson. If it's outside the interval 0 to 2 pi, it's not going to happen too often. We just got to figure it out. All right, so find the following trig values. Sine of 0. Okay, with these, I'm still going to recommend that we draw a diagram every time. It's going to get a little bit crowded, but I'm going to draw a new diagram for each one. I'm just going to zoom way in. All right, so sine of 0. So I'm gonna need a thinner pen, I think. All right, so theta equals 0 is right over here. Okay, on the unit circle, that's all the way to the right. So that's going to be where x is 1 and y is 0. Okay, the vertical displacement, that's the sine. That's how far up or down did I go. Okay, I didn't go any direction. I'm on the x-axis. That's 0. Okay, so over here, cosine of 0. Okay, again, drawing theta equals 0. I'm at the point where x is 1 and y is 0. Okay, cosine is like the x-coordinate on the unit circle, so I'm going to say that's equal to 1. Okay, it's the horizontal displacement from the y-axis. Okay, tangent of 0. Okay, you don't have to draw the unit circle if you don't want. You just have to draw the point on the unit circle and know the coordinate. That's where x is 1 and y is 0. Okay, tangent is y over x, so that would be 0 divided by 1. And 0 divided by a number, that's just fine, as long as you're not dividing by 0. 0 divided by 1, that's going to be 0. All right, back over here, sine of pi over 2. Now I'm going to go over to pi over 2, and maybe I'll draw these in red. Okay, pi over 2 is up at the top. That's going to be where x is 0 and y is 1. The vertical displacement from the x-axis, I've gone up 1 unit, so I've got positive 1 right here. You can also think of it as the y-coordinate. Okay, cosine of pi over 2. Again, drawing the same thing here. Okay, it's the coordinates, the point, x is 0, y is 1. The horizontal displacement from the y-axis is 0, because I'm on the y-axis, or the x-coordinate is 0, so cosine of pi over 2 is 0. Tangent of pi over 2. Maybe on this one I'll draw the circle, because that's what I would typically do like in the calculus class, and just that doesn't look very good. Okay, at the top of the circle, that's where x is 0 and y is 1. Okay, remember, tangent is y over x, so that would be y over x is 1 over 0. Division by 0 is undefined, so I'm going to say does not exist, D and E. Or you could say undefined if you wanted. Really, any, no, I feel like would be, I could reason with that. I know what you mean by that. Okay, sine of pi. Now we're moving on to pi. So pi is at the far left edge of the circle. I'm going to keep drawing the circle, because I think that's probably going to be what's best for us. Drawing it over here, getting the coordinates of the point, that's where x is negative 1 and y is 0. Because when I draw this, I'm always assuming it's a circle with radius 1. Okay, sine is the vertical displacement from the x-axis. How far up or down did I go? It's the y-coordinate. That's going to be 0. All right, cosine of pi. Once again, draw the circle, find the theta value, that's pi, that's on the far left edge, write down the coordinate, x is -1, y is 0. And cosine is the x coordinate, that's -1. It's also the horizontal displacement from the y-axis. I had to go 1 to the left, that's a displacement of -1. And then tangent of pi, draw the same diagram. It's where x is -1 and y is 0. Tangent is y over x, so 0 over -1 is 0. Right, sine of 3 pi over 2. I'll switch the color again. Right, 3 pi over 2 is down at the very bottom of the unit circle. So be down here, this is where x is 0 and y is -1. Right, so sine is the vertical displacement from the x-axis. I've gone down 1 unit. So the vertical displacement is -1, or you say it's the y-coordinate. Cosine of 3 pi over 2. Okay, down here at the bottom, x is 0, y is -1. The horizontal displacement from the y-axis would be 0, because I'm on the y-axis, I didn't go anywhere from it. Or you could look at the x-coordinate. Tangent of 3 pi over 2. 3 pi over 2 down here, x is 0, y is -1. Tangent is y over x. Division by 0 is undefined, so I'll say that does not exist. All right, 2 pi, that's the exact same as 0, but we'll draw it with a different color as if it's different. Okay, I'm going to put it there. That's the coordinates of this point are x is 1 and y is 0. Sine of 2 pi is the y-coordinate, that's 0. It's the vertical displacement from the x-axis. Cosine of 2 pi, horizontal displacement from the y-axis. Okay, looks like I went right to 1 unit. Okay, so the horizontal displacement will be 1. Okay, tangent of 2 pi is going to be the same as tangent of 0, but, I'm going to just draw the diagram new every time. Nope, x is equal to 1 and y is equal to 0. Okay, so tangent is y divided by x, so that's going to be 0 divided by 1, which is going to be 0. Nothing wrong with dividing 0 by a number. Okay, now these are like reciprocal functions. I think we put these off like kind of looking separate so you would draw a separate diagram, but I've been drawing a separate diagram the whole time, so I'm just going to keep doing that. Okay, cosecant of 0. Draw a circle. Find the spot. Okay, that one was pretty bad, but you get the idea. X is equal to 1 and y equals 0. Okay, sine of 0 equals 0. So cosecant of 0, I'm thinking, all right, I'm going to take that 0 and say 1 over that 0. And that's going to be undefined. So I'm going to say cosecant of 0 does not exist. Secant of 3 pi over 2. Okay, I'm going to go over here. I'm going to draw the circle. 3 pi over 2 is down at the bottom, and that's something we kind of just got to know. Coordinates of this are x equals 0, y equals -1. Okay, well, we would need cosine of 3 pi over 2 to make a determination on secant. Cosine of 3 pi over 2 is 0. So I'm going to take 1 over that 0, and that's going to also not exist. Okay, but not all of these are going to non-exist. Okay, I think we're going to see some of these are going to end up being 1 or maybe 0 or something like that. All right, cotangent of pi over 2. Okay, cotangent is x over y because tangent is y over x. So pi over 2 is right here. The coordinates x equals 0, y equals 1. Okay, cotangent is x divided by y, and 0 divided by 1, that's going to equal 0. Cosecant of 3 pi over 2. Here we have the place where x is 0 and y is -1. Okay, in order to make a determination about cosecant, we need sine. Okay, so I'm saying that sine of 3 pi over 2 equals -1, so that means that cosecant of 3 pi over 2 equals 1 over that -1, and that's going to equal -1. Okay, where's it? Okay, secant pi. All right, so I'm going to need cosine of pi, and then I'm going to flip that one. Okay, pi is over here on the far left edge. The coordinates are x is -1 and y is 0. All right, for secant, I'm going to need cosine, so I'm going to say, all right, cosine of pi equals -1. That's what I determined there. As a result, I'll say secant pi equals 1 over that same -1, and that's going to equal -1, just like the last one did. A cotangent of pi, do that one. Find pi on the circle, that's the far left edge. The coordinates are x equals -1 and y equals 0. Cotangent is x divided by y. So I'm going to have -1 divided by 0. That fails to exist, so I'm going to say it does not exist there. All right, moving on to the next page. Oh, but there's only 3 pages on this homework. I just worked the previous homework, and that one was really long. It's kind of a relief to see that this one is not going to be as long. What are the coordinates of the point where the terminal ray located a measurement of theta? Oh, we did this problem on the last homework. Given r and theta, what are x and y, basically? Okay. And just like I did on the last video, I'm going to just emphasize that these coordinates, these are going to be x and y coordinates. Okay, because eventually we'll have our theta coordinates that are, well, exactly what you can see there. All right, theta equals pi and r equals 2. So what I'm going to do is I'm going to draw what it would look like on the unit circle. Okay, over here, theta equals pi. That would be the point -1 and 0. Okay, but if r equals 2, the circle is going to get twice as large. So the x-coordinate and y-coordinate will both double. So I'm going to say that the coordinates of this thing would be -2 and 0. Okay, 2 times -1 and 2 times 0. All right. Theta equals 3 pi over 2 and r equals 4. Okay, when r equals 1 on the unit circle, down here the coordinates would be x equals 0, y equals -1. This thing's r equals 4 is 4 times as large, so I'll have 4 times 0 and 4 times -1. Theta equals 0 and r equals 8. Okay, when theta equals 0 and r equals 1, I'm at the far right edge of the circle. That's where x is 1 and y equals 0. 8 times as large would be 8 and 0. I like these a whole lot better than the ones where I had to draw the triangle. They're going quick. All right, theta equals 2 pi. That's like theta equals 0. I thought maybe these were going to be some that were going to go outside of 0 to 2 pi. 2 pi is right there. That's the coordinates 1 and 0. Radius equals pi. Hey, don't trip on that. We're just going to do the exact same thing. That's how much bigger this circle is than the unit circle. Okay, it's pi times as large, so 1 times pi and 0 times pi. Okay, theta equals 3 pi over 2, and radius equals e, that weird number that was between 2 and 3 and that we don't need to be afraid of. Nothing wrong with e. It's just some number. Now down here, this would be the point where x is 0 and y equals -1 on the unit circle. I'm going to scale it up by e, so it'll be 0 times e and -1 times e. Okay, r equals pi, theta equals pi. Okay, we'll start with the r equals 1 circle. Okay, theta equals pi is over here on the left edge. That's where x is -1 and y is 0. Okay, so if it was pi times as large, I'd have -pi and also then 0 pi. All right. Now, given the coordinates of the point, what is the radian measurement theta? I'm going to say, because, we kind of have the ability to go outside of it now, I'm going to say on the interval 0 to 2 pi, including 0 and not including 2 pi. And a radius r of a circle that intersects with the point equal to, I don't really follow that sentence, but it's all right. I know what we're looking for. Okay, at the point 4 and 0. Okay, r, the radius, that's the distance from the origin. It's going to be 4. And theta is, well, how much angle is there? Well, that's theta equals 0. Okay. Negative 3 and 0. I'll draw the diagram for each of these. Okay, this looks like theta equals pi, right? Because we're going all the way over here. Theta equals pi. R is the distance, is the radius of the circle. That's looking like it's going to be 3. Okay, over here is 0 and negative 10. X is 0, y is negative 10, so that's all the way at the bottom. Okay, that's theta equals 3 pi over 2. And r is that vertical distance, so that would be 10. Right, 0 and 6. Oh, unfortunately, these are going to eventually not all be as easy. But x is 0, y is 6. So I'm up here at the top of the circle. That's theta equals pi over 2. Radius of the circle will be 6. 8 and negative 8. Now, I'm going to have to put in a little bit more work because this isn't at one of the extremes. Okay, I always know I'm at one of the extremes if I see one of the coordinates is 0. But neither of these coordinates are 0. So x is 8 and y is negative 8. So it's going to be right here. We don't know what the radius of the circle is quite yet, so we're going to draw ourselves a little reference triangle. This is eventually, oh no, I guess I've been drawing the amount of rotation in blue. Okay, now 8 and negative 8. So coordinates, x and y coordinates are the same. That's going to be, kind of along the line y equals negative x, which would cut the fourth quadrant in half. This is a 45-degree angle. What I'm saying is it's short of 2 pi by pi over 4. So 2 pi minus a pi over 4. That's 8 pi over 4 minus 1 pi over 4. That will be 7 pi divided by 4. And then the radius, we're going to need that triangle. We have the x is 8 and y equals negative 8, and then I'll say that this is r right there. All right, so r squared is going to equal 8 squared plus negative 8 squared. It's r squared equals 64 plus 64 is 64 times 2, because I know where this is headed. And then, wait, pardon me, r squared equals 64 times 2. So r equals the square root of 64 times the square root of 2, and that's 8 root 2. Because we're interested in r being a positive number. I think the last one, yep, here we have one that's going to be a 30, 60, 90 triangle. Both of them are negative, so I'm going to just only draw the third quadrant. I could do better than that. I guess I don't want to only draw the third quadrant. We'll draw it here. I'm kind of favoring it. Negative 2 and negative 2 root 3. Root 3 is bigger than 1, so I'm going to be farther down than I am to the left. So I'm going to draw that point down here. This amount of rotation looks to me like 4 pi over 3, because it looks like 60 degrees beyond pi. So that would be pi plus a pi over 3, which is 3 pi over 3 plus an additional pi over 3. Going to be 4 pi divided by 3. All right, then the radius, yeah, I think that, we could think about it with 30, 60, 90 triangles, and if you would prefer that, you can feel free to do that. Or what we could do is we could just label the side lengths. I think it's going to be 4. Because I've done a few of these problems today. But if you haven't, then what you should do is say, all right, x squared plus y squared equals r squared. So it would be 4 plus, well, if I square the negative 2, I'm going to get 4. And then if I square the square root of 3, I'll get 3. Okay, 4 plus 12, oh yeah, 16 equals r squared. R is going to be 4. Okay, and I think it's good that we got back to the special right triangles because those are really important for us. All right, now give coterminal angles to the following radian measurement in the interval negative 2 pi to 0 as well as in the interval 2 pi to 4 pi. Yeah, so we're going to go kind of because all of these are in the standard first trip through the unit circle. We're going to go back one trip through the unit circle by subtracting 2 pi, and we're going to go ahead one time as well. So I'm going to kind of, we could do this without drawing the diagram, but I want to remind you of where all these angles are. So 5 pi over 6, almost all the way to pi. That's right here. Okay, so that's 5 pi over 6. If I was there and I went around another time, I'd have 5 pi over 6 plus 2 pi, so that's 12 pi over 6. And that's going to equal 17 pi divided by 6. So that's a coterminal angle. But I could also go backwards by 2 pi, and I could subtract 2 pi. So 5 pi over 6 minus 12 pi over 6, that would be, let's see, 5 minus 12, I think it's going to be negative 7 pi divided by 6. Okay, yeah, so I've got 1 in the interval negative 2 pi to 0, and I'm going to do those in blue, and then I'll also have 1 in the interval 2 pi to 4 pi, which is 17 pi over 6. Yeah, it's between 2 and 4 pi. All right, 4 pi over 3. Let's start by reminding you where that is on the unit circle. Think about adding a whole rotation. That would be 4 pi over 3 plus 2 pi. That would be 10 pi over 3. And then I could also think about going backwards by one rotation. And that would be 4 pi divided by 3 minus 6 pi over 3, and that would be negative 2 pi over 3. Now, if you can just kind of look at these and think about, especially the negative version of the angle, if you're to that point where you can go and think about it, good for you. Go ahead and do it without the arithmetic. I'm just going to show all the steps that I can in the video just in case anybody's confused. All right, then pi. All right, I think with this one, I'm going to say pi plus 2 pi equals 3 pi, and then pi minus 2 pi equals negative 1 pi, because I don't think a whole lot of support on the arithmetic there. We're just going to point out that 1 pi, 3 pi, and negative 1 pi all belong at that spot, so that's all of our odd numbers of pi there. All right, 3 pi over 4 radians. Pi's over 4 represent 45-degree reference angles. 3 pi over 4 is almost all the way to 1 pi, so that's over there in the second quadrant. If I went one rotation farther, I'd have 3 pi divided by 4 plus 2 pi, which would be an 8 pi over 4. That would give me 11 pi divided by 4. And then if I were to decide to go back by one full rotation, I could take 3 pi over 4 and subtract 2 pi. And that would be negative 5 pi divided by 4. All right, 11 pi over 6. That's almost all the way to 2 pi. It's the last stop before 2 pi. So that's over here. If I were to go a whole other time around the circle, so this one should be really close to 4 pi, right? If I have 11 pi over 6, which was already close to 2 pi, and I add an actual 2 more pi, 12 pi over 6, that'll give me 23 pi over 6. And that feels right. That's like, almost 24 pi over 6, which would be 4 pi. If I went backwards. It looks like negative pi over 6. And I think it's probably actually easier to think about it, just looking at it than it is to think about the fraction arithmetic. But, it's also good to see how it works on that level too. So 11 minus 12 is negative 1 pi divided by 6. And pi over 2, that one's up at the top, as we've been pretty aware of today. So if I went another trip around, I'd have pi over 2 plus 2 pi. That would be 5 pi over 2. Then if I went backwards one rotation, I'd have pi over 2 minus 2 pi. And that would be negative 3 pi over 2. Okay, so that was us finding coterminal angles. We add 2 pi, we subtract 2 pi. That's all we do. Now, if we're writing an expression for all the coterminal angles, okay, that would be where we would say, well, plus any number of times around the circle, any number of 2 pi's. So pi over 3, plus 2 pi, pi over 3 minus 2 pi, pi over 3 plus 4 pi, which would be 2 pi's. So what we would say is the expression is going to be pi divided by 3 plus 2 pi n. And I'll just tell you, I don't need the disclaimer in my class. Maybe if you took the actual college version of this class, you would be required to give the disclaimer here about what you meant by n. We mean that n is an integer. And so we say that n is an element of the set of all integers. Okay, so you'll see me write that each time I use that notation, but I don't think that you're going to need that. That said, a person might need to be able to recognize that notation. Coterminal angles will be 5 pi over 6 plus 2 pi n. Like in a multiple choice situation, I can't say for sure. We'll know more about that when we go to solve trig equations, because that's where this is going to come back up, where n is an integer. Okay. N could be a positive or negative whole number. That's what that means. It's a set of integers. And then for 0, we could say 0 plus 2 pi n, or we could just call that 2 pi n, because adding 0 doesn't really do anything, so I feel like that might be a little bit more world aware for us to write it as 2 pi n, where n is an integer. All right, so this last set we've got, this is going to be where we're going to go beyond 0 to 2 pi, in the negative realm and in the beyond 2 pi realm. And so what we're going to do is just the same 3-step process as always. Find the spot on the unit circle. That'll be a little bit more difficult than usual, but not that bad. Then we'll draw a reference triangle, and then we'll do SOHCAHTOA, and it'll be great. All right, so I feel like the first step here is identifying that this is bigger than 2 pi. 2 pi would be 12 pi over 6. This is 17 pi over 6. That's way bigger. All right, so I'm going to kind of start with the analysis that 17 pi over 6 is going to be 2 pi plus something. 12 pi over 6 plus 5 pi over 6. So what I'm saying is angle 17 pi over 6 is coterminal to 5 pi over 6. That's where I'm going to go on the circle. Draw myself a little diagram. Find 5 pi over 6, it's over here. Draw myself a reference triangle. Okay, 1 over here. The short leg is a half, and the long leg is root 3 over 2. This pen's a little too thick. Hey, x is negative, y is positive. Sine is opposite over hypotenuse. 1/2 over 1, that's going to be a half. Right, cosine of negative 10 pi over 3. Okay, this one's not in the negative 2 pi to 0 either. This is more negative than negative 3 pi, so we're just going to have to figure out what this one is. Let's say negative 2 pi, which would be all the way back to 0, would be negative 6 pi over 3. So yeah, I'm just going to go from there. If you're wanting to go from, what would I say, negative 12 pi over 3, I actually think that might be a better way to go, but I don't think that's probably what y'all would think first. So negative 2 pi would be negative 6 pi over 3. And then I'm going to go minus 4 pi over 3. Okay, so it's going to be equivalent to negative 4 pi over 3. And if you're, oh man, that one was good until the very end. That'll have to be good enough. If you're okay to say, okay, negative 4 pi over 3, that's going to be up here. Okay, that's fine. But if you don't like that, we could say, all right, I've got negative 4 pi over 3, and what I would suggest you do with, normal negative angles is add 2 pi to them to see what they're coterminal to, so that would be plus 6 pi over 3. And see, I messed it up. Yeah, so that's why you should do this. That would be negative 5 pi over 3 there. I see that now. So that's going to give me 2 pi over 3, and 2 pi over 3 is in the second quadrant. So that's over here. Draw myself a reference triangle. This will be negative 1/2 root 3 over 2 and positive 1. Cosine is adjacent over hypotenuse, so 1/2, or negative half divided by 1. So it's negative 1 over 2. Tangent of 11 pi over 4. That's bigger than 2 pi because 2 pi would be 8 pi over 4. So 11 pi divided by 4 is going to equal 8 pi divided by 4 plus another 3 pi divided by 4. So this angle is coterminal to positive 3 pi over 4. And I'm not going to draw the circle because my diagrams were getting a little crowded. Negative 3 pi over 4, or pardon me, positive 3 pi over 4 is over here. And I'm going to draw my triangle. Okay, it's a 45, 45, 90 because it's a pi over 4. Hypotenuse is 1, legs are both root 2 over 2. For here in the second quadrant, x is negative and y is positive. Tangent is opposite over adjacent, root 2 over 2 divided by negative root 2 over 2. That's going to be negative 1. All right, secant of negative 7 pi over 6. Okay, that's just a regular negative version of a unit circle place we know. If you're good if you're good at finding negative 7 pi over 6 on a circle without going into arithmetic, good for you. Go ahead, do that. But oh wait, pardon me. I'm kind of thinking backwards here. 2 pi would be 12 pi over 6. If I add 2 pi to it, I'll get a coterminal angle that might be a little bit more obvious to the majority of students in my class. 5 pi over 6. We know where that is. We're going to start there. 5 pi over 6, almost all the way to pi, just short by pi over 6. So I'm going to have a 30, 60, 90 triangle. I've gone up by 30 degrees there, so that's my reference angle. Got a 30, 60, 90. Hypotenuse is 1, short leg is a half, long leg is root 3 over 2. I'm going to check for what should be negative. Okay, I think that one's going to be negative there. Now think about secant. Well, I'm going to need cosine first. So cosine of negative 7 pi divided by 6. That's going to be adjacent over hypotenuse, negative root 3 over 2. As a result, secant of negative 7 pi over 6 will be negative 2 over the square root of 3. I might be interested in rationalizing the denominator there. I'll get negative 2 square root of 3 all divided by 3. Okay. Cosecant of negative pi over 4. Honestly, I want you to be to the point where negative pi over 4, you can just say, oh, okay, instead of going forward, I'm going backwards. It's 45 degrees. I've got this. I don't need to add 2 pi to get a coterminal angle. I really hope you're close to that point. And if not to that point where you could do that on your own, to where at least to where you could believe me when I say, okay, I'm just going to go down by pi over 4 instead of up because I'm going negatively. Okay, this is a 45, 45, 90 triangle. My hypotenuse is 1. The legs are both root 2 over 2. Once I label the legs, I need to check for what's going to be negative and what's going to be positive. Okay, down here, that'll be a negative number. Cosecant is going to be related to sine. I'm going to start by finding sine of negative pi over 4. It's going to be opposite over hypotenuse, negative root 2 over 2. As a result, I'm going to have cosecant be negative 2 over the square root of 2, which I think we've reduced enough times that we're just going to hopefully recognize that that's the negative square root of 2. Maybe, I don't think I've done this on screen. I think I've mentioned this verbally or worked with some people on their own sheet of paper on why this is true. But I'm just going to point out, hey, remember 2? I mean, a person wouldn't normally want to write it like that, but you could think of 2 as square root of 2 times square root of 2. And then you can cancel like that. That's a different way to rationalize the denominator, just by getting rid of it. But that's another reason why this is going to equal negative square root of 2. Next, 17 pi over 4. Oh, man. So, I think what I'm going to do is 2 pi is 8 pi over 4. 4 pi is 16 pi over 4. Yeah, okay, so this is 4 pi and then a little bit more. So, but maybe you didn't realize that. Maybe you're saying, all right, it's 8 pi over 4 plus something. And you're like, oh, okay, it's 9 pi over 4. And then you're thinking, wait a second, I don't even know what 9 pi over 4 is. That was my coterminal angle, was positive 9 pi over 4. It's like, okay, well, 9 pi over 4, that's still bigger than 2 pi, so that's equal to 8 pi over 4 plus another pi over 4. So another coterminal angle would be this positive pi over 4. So I'll draw my reference triangle, pi over 4. That one's about as easy as it gets. So standard 45, 45, 90 triangle. In the first quadrant, everything's going to be positive. So cotangent is going to be x over y. That was kind of the shortcut we developed in this lesson. So the horizontal leg is root 2 over 2. The vertical leg is root 2 over 2. It's some number divided by itself. That's going to equal 1. And I know we got still 6 more of these, but these are, this is the practice we need at this point. Okay, cosine of negative pi over 6. You've got this. You don't need to find a coterminal angle. Yes, it's the same as 11 pi over 6, but you can just visualize negative pi over 6, I hope. And then, our 30, 60, 90, hypotenuse is 1, short leg is a half, long leg is root 3 over 2. Once you get those legs labeled, we're going to check to see which one's negative. Okay, the one that corresponds to y is going to be negative because I'm down here in the fourth quadrant. And cosine is adjacent over hypotenuse. That's square root of 3 divided by 2. Okay, secant of negative 7 pi over 3. Okay, I'm just going to try to find a coterminal angle by adding 2 pi. So that would be add 6 pi over 3. And I'm going to get negative pi over 3, which is still a negative angle. But again, this is one of these where if it's just negative of pi over 4, pi over 3, pi over 6, it's going to be in the fourth quadrant. It's not any harder than finding regular pi over 3. You just go in the opposite direction. Okay, regular pi over 3 would go up by 60 degrees, so I'm going to go down by 60 degrees. Draw myself a reference triangle. Okay, it's a 30, 60, 90. That's my reference angle. Hypotenuse is 1, short leg's a half, long leg is root 3 over 2. Once I get the legs labeled, I'm going to check to see what needs to be negative. That'll be the root 3 over 2. And then secant, if I want secant, first I need cosine. So cosine of negative 7 pi over 3 is going to equal adjacent over hypotenuse. So that's 1/2. As a result, secant will equal 2 over 1. And I'm just going to say that's 2. Cosecant of 14 pi over 3. All right, so that's way bigger than 2 pi. So that's 6 pi over 3 plus 8 pi over 3. So the first coterminal angle I've come into contact with, is 8 pi over 3. Okay, but that's still bigger than 2 pi, so that's equal to 6 pi over 3 plus 2 pi over 3. So that's going to be a coterminal angle as well, 2 pi over 3. That's the one I'm going to draw. So 2 pi over 3 is short of pi by pi over 3, so I'm going to go back up by 60 degrees. That one was a pretty bad right triangle, but it'll do, right? It's not about the exactness of it. The short leg's a half, the long leg is root 3 over 2. Check to see what should be negative. That's going to be the half. And cosecant, in order to find cosecant, I need the sine. The sine of 14 pi over 3 is going to equal root 3 over 2. So I'm going to have 2 over square root of 3, and I'm going to rationalize the denominator on that fraction for about the 40th time this unit, and I'm going to get 2 root 3 over 3. All right, now, oh boy, 15 pi over 2. So on this one, we're going to need to find the nearest number of 2 pi's that's underneath that. So that would be, I think, 12 pi over 2 would be 6 pi. It's an even number of pi's. Yeah. Okay, so I'm going to say 6 pi equals 12 pi over 2. And 6 pi is coterminal to 0 because it's an even number of pi's. Okay, 15 pi over 2 is going to equal that 12 pi over 2, which is coterminal to 0, plus 3 more pi over 2's. All right, so what I'm concluding is that this is just equivalent to finding the sine of 3 pi over 2. Which I'm glad we're bringing it all the way back around to the extreme values. I'm down here at the bottom, so there is not a triangle to draw. I go to the coordinates. X is 0, y is negative 1. It's asking me for sine. Sine is the vertical displacement from the x-axis. That's the y-coordinate. That's negative 1. Right, cotangent of negative 25 pi over 6. All right. What I'm going to do is I'm going to add a multiple of 2 pi. I know that 24 pi over 6 would be 4 pi. So I'm going to add 24 pi over 6 to get a coterminal angle. That'd be just going forward 2 rotations. Now I would get negative pi over 6. And that's going to be good enough for me. I can work with negative pi over 6. And so I'm going to go down here, 30 degrees down. Okay, hypotenuse is 1, short leg is a half, long leg is root 3 divided by 2. I'm going to check to see which of these legs needs to be negative. I think it's going to be the half. Okay, and then to get cotangent, I'm going to do adjacent over opposite, or, the x-coordinate divided by the y-coordinate. So root 3 over 2 divided by negative 1/2 is like multiplying by negative 2 over 1, and I'm going to get negative square root of 3. And now the last one, I just gotta think this is so far outside of the interval 0 to 2 pi, this is not the type of thing you'd ever see again. 19 pi over 3. Okay, so what would be the nearest number of like even pi's? Okay, I think 6 pi would be 18 pi over 3, yeah. 18 pi over 3 equals 6 pi, and an even number of pi is equivalent to 0. So 18 pi over 3 plus a pi over 3 equals 19 pi over 3. So I'm going to conclude that pi over 3 is the coterminal angle. Right, and I'm going to go over here and draw myself a reference triangle that's, I don't know why I put that y-axis there, I probably want it there. Pi over 3 is up 60 degrees, draw 30, 60, 90 triangle. Hypotenuse is 1, short leg is a half, long leg is root 3 over 2. Need to check to see what's going to be negative. Nothing's going to be negative because I'm in the first quadrant. Tangent is opposite over adjacent. Okay, so root 3 over 2 divided by a half. I'm going to keep the top the same, change the division to multiplication, flip the bottom, and get square root of 3. I think, yep, that's all the problems on this homework, so that's going to be all for this video. Thanks for watching.